And we're recording. All right, this is Math 7, and today we are doing similar triangles and indirect measurement. This is located in your book. It's lesson IN25, found after page 550. We have some vocabulary words that we need to go over, and one of the vocabulary words is indirect measurement. This allows you to use properties of similar polygons to find distances or lengths that are difficult to measure directly. I know you still don't have an understanding of what that means yet, but it's okay. Direct measurement is your arm. You could measure your arm. It's reasonable. An indirect measurement is the Statue of Liberty's arm. You can't just get a tape measure and go measure the Statue of Liberty's arm. It's something that would be considered an indirect measurement. Now, we're not going to take time to write out the parts of this page on IN25, so we're going to turn it and go to the next page where we have our official boxes with the words and formulas. It says, if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. Okay, circle the word congruent. Congruent, does anyone in here know what congruent means? Yes.
Like vertical angles that are right next to each other.
Okay, vertical angles are congruent, but I need to know why. Cooper.
They never cross.
That is not the reason why they're congruent. Tinsley.
They're the same.
They're the same. Congruent means same measure. They're the same. And in this case, they have the same measure since they are angles. Angles have the same measures, okay? So, this is how you would read this. If angle A is congruent, that's the symbol for the word congruent. If angle A is congruent to angle F, angle A and angle F. See how they both have one little arc? That means they're the same measure. And angle B and angle G are congruent. Notice how B and G, they both have two little arcs, okay? Then triangle ABC, that's the symbol for similar, is similar to triangle FGH, okay? If you have two angles that are if your triangle, let me say that again. If two triangles have two angles that have the same measure, then the third one is also going to be the same. That's just a given, okay? So, now let's look at what this means. In the figure below, angle X is congruent to angle P, and angle Y is congruent to angle Q. If you extend the sides of each figure to form a triangle, you can do that on your paper right now, you can see the two triangles are similar. One's just bigger than the other. Similar means same shape but different sizes. So, the triangle similarity can be proven by showing two pairs of corresponding angles are congruent. Okay, X is congruent to P and Y is congruent to Q. Okay, notice how I put two little arcs there. All right, let's go on. Oh, it says stop and reflect. What do you know about the third pair of angles in the triangle? They are also congruent, aren't they? That was one of those. Okay, now let's go on to example number 1. Are you all understanding how to read geometry things, the congruent symbols? Okay, so make sure you know that what the word for similar looks like, or the symbol for similar and the symbol for a congruent are. All right, here we go. Determine whether the triangles are similar. If so, write a similarity statement. Okay, angle A and angle E have the same measure. They both are 62, aren't they? Okay. So they are congruent. Those two angles are congruent. Since 180 minus 62 minus 48 equals 70, angle G must be 70 degrees. Okay, now let's stop right there. All triangles, when you add all the angles together in a triangle, it equals 180 degrees. So the angles in a triangle equals 180 degrees. Did you know that?
No.
That's a 6th grade standard. You have to know it. It'll be on your iLearn test. So over here, let's just take a few notes. The triangles equals 180 degrees when you add all angles, when all angles are added. And a quadrilateral, this one you might know. How many degrees are in a quadrilateral? 360. When you add all the angles. And in a quadrilateral there are only 4, and in a triangle there are 3. So if you know 2 of your angles in a triangle, you can always figure out the third one, right? And that's what they were showing you here. So, you know this is 62, that's 48, so 62 plus 48, subtract it from 180, you get 70. That's how they got 70, okay? Now we want to see if these are congruent. Well, here you have a 62 and a 70. 62 plus 70 is 132, and 180 minus 132, that will give you a 48. Are these triangles similar?
Yes.
They are, because they all have, so this is a 62. I'm going to put 2 arcs by the 70, and I'll put 3 arcs by the 48. Okay, so notice how you can compare them with the arcs. 3 arcs, 3 arcs, 2 arcs with the 70s, and I used 1 arc with the 62. So that's how that's what you'll see how they communicate with each other too. All right. Now let's apply this and look at letter A. All right. Well, here we know that this is 110 and that's 110. So what they want us to do with this information is, well, it's not very clear. I guess they want us to determine if these are similar. So we have to make some statements here. We know that angle JKH, so let's write this over here on the angle JKH, JKH is equal, or it's congruent to KLM, right? We know that it's KLM. We know that angle L is congruent to angle H. Another way we could say it is angle L is congruent to angle H. And another way, L is congruent to angle H. And then they say in the book here that triangle, so now we're going to talk about triangles, JKH is similar to triangle MKL. All right, do you have your symbols all written down correctly? Yes.
How do you know when to put similar or congruent?
Okay, when you are comparing angles, you're going to use congruent. When you're comparing shapes, you'll use similar. Okay? Now let's go on to IN27. Use indirect measurement. One type of indirect measurement is shadow reckoning. 2 objects and their shadows form 2 sides of a right triangle. In shadow problems, you can assume that the angles formed by the sun's rays with 2 objects at the same location are congruent. Since 2 pairs of corresponding angles are congruent, the two right triangles are similar. You can also use similar triangles that do not involve shadows to find missing measures too. Okay, so let's look at the shadow measurement here in number 2. We have the measurement of a light pole and the measurement of a fire hydrant. Okay, so they can measure this without a ladder. They can go and oh, this is 26. They measure the shadow as 26. They measure the shadow of the fire hydrant as 5. And we have this one, you can measure how tall it is. 2.5 is the height, but we don't know the height of that one. We set up a proportion, kids. This is what you do. This is the shadow, this is the height. The hydrant is 5 for the shadow, and the actual height of the hydrant is 2.5. The shadow of the street light is 26, but we don't know the height. So now we go back to what we did the first semester. Cross multiply and divide. You're going to take 26 times 2.5 equals 5 times h. And now it's pretty easy. 26 times 2.5 is 65. Divide both sides by 5. H equals 13 feet. Do you see how they did that?
So
Yeah.
you take the one that it shows you, so for example, the hydrant, and you take its height and its shadow, and you know the shadow on the...
It doesn't matter because it'll give you the same, but you have to be consistent. Make sure your shadows are on the left or on the right. It doesn't matter, but you have to make sure you have the shadows on top and bottom. Okay? Now we're going to do something similar in example 3, and then we'll start doing some problems. In example 3, in the figure at the right, triangle DBA, triangle DBA, I'm just going to outline that for you in yellow, DBA, so this is the triangle we're talking about, is similar to triangle ECA. ECA. Okay, they are similar. All right. Now it tells you they are. Raymond wants to know the distance across the lake. So that's where you're going to set something up. Okay, here we have line segment AB. Line segment AB we know is 320. And AC is going to be 320 plus 162. All right? Equals BD over CE. So we're comparing this side to this side and this side to this side. So we're setting it up. Okay? So we have AB over AC equals BD over CE. All right? So think of it as on the top is the small ones. It's the smaller triangle. On the bottom you have the larger or the big triangle. AC is alongside and CE is alongside. All right? Now we replace it with the numbers. So we have 320 over 482 equals 40 over mystery side D. Now you cross multiply. 320 times D equals 482 times 40. Divide both sides by 320 and D is 60.25. Any questions? This is a little deep. Yeah. You just are going to have to do it and then it'll come to you. We're going to do some practice, okay, on it. Let's go now to problem number 1. Let's practice this because it's easier to do when you are practicing these problems than when you are not. So we are on IN28. We're going to skip the part B and just go straight into the guided practice, kids. So on this it says determine whether the triangles are similar. If so, write a similarity sentence. Okay, these are similar. How do I know? I know, so are you ready to write? Angle YWX, YWX, that's an angle symbol, is congruent, it has the same size as angle UWV, okay? UWV. That's because they are what? Vertical angles, right? Why? They are vertical angles, and vertical angles have the same measure, right? Vertical angles are opposite angles. That's why they could be that way. All right, then you know that angle V is congruent to angle X because it tells you so, right? Angle X and angle V are the same. Angle V and angle, it is congruent to angle X. Okay, you got that written down? So, since you have two of the angles of the triangle are the same, they are similar. So, triangle, draw a triangle, XWY is similar to triangle UWV. All right? You only need, in a triangle, you only need to have two congruent ones because you know the third one's going to be congruent just because they have to equal 180. All right, now let's look at this one. They both have a 90-degree angle, so those are the same, aren't they? Ooh, this one's 35 and this one's 25. Well, what's in? 90 plus 35 is 125. And 180 minus 125 gives us the answer of 55. Ooh, that's not a 55, is it? No. So this would be 55 degrees. In this one, if this is 25, if I do 90 plus 25, that gives me 115. And 180 minus 115 will give you 65. They do not have the same measures, do they? So it's not similar. All right, now let's look at the shadow box. Remember, these are the shadow type problems. How tall is the tree? You're going to set up a proportion. All right, so on the proportion, you can, as long as you are consistent, let's do shadow and the height, because we have shadow, height, and when we do this, I'm going to put the little tree on top and the big tree shadow on bottom. So that's what my L stands for. L stands for, I guess it's little shape and big shape. So the little one is the fox or whatever the creature is, and the big thing is the tree. Got it? I usually put the littler above the big. All right, so my shadow. The shadow of the little thing is 0.3. The shadow of the taller thing, the tree, is 2.2. Got it? Yeah. Now, the height of the little thing is 0.45. The height of the tree, we do not know. Now we do the cross products and divide. So here you're going to have 2 2/10 times 0.45 equals 0.3 times h. Then you're going to divide both sides by what? You got to get for h. What do you do to solve for h? Divide by 0.3. Mrs. Robertson always saves you one step. Then you get your calculators out. And you take 2 2/10 times 45/100 and divide it by 3/10. So if you have a calculator, do that. If not, I'm doing it on mine. We'll need calculators now this week. 2, or next with 0.2 times 0.45 divided by 0.3. The tree is 3.3 meters tall. The height, 3 3/10 meters tall. All right. Any questions on how I got my answer? I'm going to put it up there. All right. Let's go on to, yes.
I'm super confused on how it went from 99.99 divided by 3 into 3.3. Like that made it bigger than what it was.
Well, because you're not dividing by a whole number, you're dividing by a little fraction.
When you divide by something,
Yeah. The fractions are that you're dividing by a decimal, so it's less than 1. All right? Like if you have $10 divided by a penny, how many pennies are in $10? It's a pretty big amount, right? So that's sort of like what it's doing here. Whew, this is busy. Now it says find the distance from the house to the street light. House to the street light. Okay. This distance here. Well, I know that this line is similar to that line, and I know this line here is similar to that one. Okay? So I am going to put, this time I'm going to put big over little. Big over little, because the big is on equals, and then I'll have big over little again. All right, so I know that these, because see how do I know? This line has an arc and a double arc, an arc and a double arc. So I'm going to put 8 over 4 equals, now this line here is given 5m to dm. How do I know it's similar? This one has 2 arcs, that one has 2 arcs, and it has point Z in common. So I put the bigger one on top, which is D, and the smaller one is 5. Okay? Now we're going to do our cross products and solve for D. You have 4 times D equals 8 times 5. Then divide them both by 4, and D equals 8 times 5 is 40, divided by 4 is 10, and it's 10 meters. All right. Now, I want you to go back to question 10 on your quiz, and you can do the shadow problem. This is like the shadow problem, all right? That is the last problem I think that we're going to do for today. Then turn your quiz in, and you have to find the height of the person. So you might do shadow, height. You can do it several ways. The shadow, and then you might put big on top, little on bottom. You can't do big, little, and little big on this side. You have to make sure that you're consistent. So the shadow of the big is 20. The shadow of the little is 5. The height of the big is 25. The height of the little, we don't know. And now you know how to solve it. Do you see how to do that now? Go ahead. And then I think I might, once you're finished, you can then go on and maybe try to do some problems on page IN29 until the bell rings. So if you get finished, go ahead and maybe try to do number 3 or 4. The other ones are pretty simple. Yeah.
If we don't get them done, are they homework though?
You have to get the quiz
Yes,
done.
the
Yeah.
problem.
These are just, I want you to practice. We'll practice it again next week. Yes.
Where do you want us to do
The quiz, let's put it in the green folder, okay? I will be giving you, I thought I could give you your arithmetic practice tests back today. We'll go over that Monday. Yes, Heaven.